Welcome to the Ask the Experts session of the Instron Biomedical Testing Open House, the session where you get to pepper our experts with questions for a full hour. Thank you so much for being here. I'm Nick Erickson, your host and moderator for this session. For those of you that joined some of our other presentations this week, this one's set up a little bit differently. Instead of the normal presentation followed by a short Q&A, this is purely going to be a discussion-oriented format with our panel, answering questions that get submitted by you, our audience. If you look under GoToWebinar panel, you should see a chat section where you can send us your questions. And starting right now, I'd like you to start sending your questions so we can put those into the queue. And please continue to send in your questions throughout the entire session. Any that we can't get to live, we'll address individually by email after. Moving on, to help answer your questions, we've assembled a panel of some of our leading application experts, which I'd like to introduce you now. First up, we've got Dan Caesar, one of our applications engineers that works out of our Center of Excellence in Norwood, Massachusetts. Dan's day-to-day focus is primarily on static testing applications, but earlier in his career, he did spend a few years working as a calibration engineer, which I mentioned in case you have any calibration related questions. Then we've got John Fleming, one of our field application engineers for the UK and Ireland. John has a broad range of knowledge that covers static and dynamic testing. Next up is Ralph Green, another one of our field application engineers who happens to be in his 35th year with Instron. Similar to John, Ralph has a really broad range of application knowledge and experience. He supports our Chicago and Upper Midwest regions. And finally, we're joined by Mark Shorey, who has worked with Instron for over 27 years, currently working on our dynamic system side of the business in the US. He primarily works with customers performing dynamic and fatigue testing applications. So between all of them, that's 70 plus years of materials testing experience. So I'm very happy they could join us for this session. And I think I've talked enough. Let's get started with our first question. So let me just pull this up, and actually I'll drop the slide. Let's see here. So the first question is, recommended concentricity requirements needed for lure torque testing and why? Let's see here. Oh, I think Ralph, you might be muted. We'll work through the kinks here on this first question. There we go. Perfect.
So yeah, I should be unmuted. So I only raised my hand because nobody else is raising their hand. So I've had a little experience with lure testing, and I will say I don't know of an exact requirement for the concentricity, but I do know that you do need to make sure that you're able to smoothly insert and withdraw. You don't want to have these two off to where they're going to hit, obviously. So you need to be able to smoothly insert and withdraw, and then wind it up, unwind it, and then back off and be able to bring it back down again to the same place every time. Now, if your system, I don't know what you have, but if your system is off slightly, you could have something like an XY stage or different fixtures to bring these into where they need to be.
All right, Dan.
Yeah.
Yeah, and to add on to that, why it is important is because depending on what type of load cell or biaxial load cell that you're using, that off-axis loads can occur. So that's going to invalidate some of the load reading or the torque reading that you're seeing. So obviously we want to ensure that the measurements that we're taking are valid. So if you even have a millimeter or two of off-axis fixture to fixture or product to fixture, that you should expect some amount of off-axis force or torque inaccuracy.
Yeah, and I'll jump in here as well and speak about the what I've done on the dynamic side of things in the past, and that is the fixtures which are used on dynamic systems often have a little bit of an adjustment in there, and so we can set the lower fixture and leave it loose on the T-slot table, bring the actuator down so that the lure comes into contact and make sure that it's concentric by using the fixturing, which is, Ralph, what you were talking about as well. Once it's centered and we come up and down a few times and make sure that it's concentric, then we tighten everything in the final amount. And this helps us with the load cell, as Dan has said, and it also helps with the test itself so that we know we're not getting any side forces through the sample, which could affect the result. So, but it's certainly on the dynamic side of things, we use the fixture itself as just a little bit of an adjustment to make sure that we are concentric. And I think, Ralph, as you said, I'm not aware of any specific standard for concentricity as measured. The normal practice is to make sure that the fitting, the connection between the two parts are nice and clean and true. But I don't know of any specific standard for that.
All right. Feels like we got a good, well-rounded answer on that one. So we'll move on to the next question. Are there any differences on the 6800 series? Oh, Ralph, you gotta.
We'll continue with the question, but okay. I'll take this one.
All right. Are there any differences on the 6800 series cause for all Blue Hill methods developed on a 5900 series frame to be re-evaluated?
So so I just dealt with this recently over the past couple of weeks. The initial thinking was you would not have to do a complete revalidation, that we could just say, here are the things that are different, and you could then move on from the 5900 to the 68 and just do what we call, say, a partial validation, if you will. But I just had a conversation this week, Monday and Tuesday, with the team, and the consensus is now that there are enough differences between the 59 and the 68. Just think about the states that are involved, where there's now we have a disabled state, a setup, warning, and a testing state, as well as things like collision mitigation and some other new safety features that are just built in behind the scenes. Those differences are enough to say that, yes, we need to do a complete full IQ-OQ when you're moving from 59 to 68. So that's our recommendation.
All right, Dan, go ahead.
Yes, definitely. Ralph is 100% correct. And then another set of our customers who validate to a particular version of our Blue Hill Universal software, that you may have been validated to, say, 4.08 on your 5900 system, but we cannot offer that version for 6800 series. So we released the 6800 series on, I believe, 4.21 or around that, that's where we're on now. I think we released it on 4.18. So that by itself might force, and that does force a lot of our customers to perform the revalidation on the new version of the software.
All right, yeah, go ahead, John. Well, I think you might actually be muted still, so check that real quick.
Can you hear me now?
Yeah, you're good.
Sorry, I just want to add in the comment here. So yes, no, we have the differences in software and the actual operation of 6800 compared to 5900s, but we need to remember the other part of it, the actual, we'll say, specifications and so on. You may not, you wouldn't need to necessarily, you won't see differences in performance, we'll say, final results and so on. So I suppose that's going to make the revalidation easier from the perspective of not having to reset specifications, not having to change procedures and so on.
All right, feels like we're all set on that question. Hopefully that answers that. I know a number of you have arrived after I kind of did the quick introduction here. Just kind of want to put it out there again. We are answering questions on pretty much anything biomedical related. So for those of you that arrived after I kind of mentioned it, in the GoToWebinar panel, there's our chat. Toss your questions in there. We're going to put it into our queue of questions, and we'll try to get to everything within the hour. And if we can't, then we'll just follow up by email. So just kind of keep that in mind. And welcome to the webinar for those of you that just got here. So kind of continuing on down with this list of questions, we're gonna answer. Next up, I see there is this question: what is the best method to measure Young's modulus, young modulus of soft tissue?
So this is a good question. It can be difficult, and it really depends on what the specimen that we're looking at is. So what is the size of your sample? Is it only 5 millimeters long? Is it 10 millimeters long? A couple inches long? And then how sensitive is your material? So if you have an incredibly small sample, you're probably not going to be very successful testing this in tension. So you might be pointed towards a compressive Young's modulus. That being said, you also probably want to look to see how this tissue is being used in the body. So is it actively used in tension? Is it actively used in compression while it's in the human body, or any other biomedical, any other body you're talking about? So that might lead you to say, I need to know this value as a tensile Young's modulus. So those are a couple things to consider.
Okay. Anybody else have anything else to add to that, Ralph?
So yeah, with the Young's modulus, a lot of times you can use the video extensometer for measuring strain. Sometimes if the specimens are very small, as Dan noted, 5, 10 millimeter, you may not have enough room to put dots on the specimen, but maybe you could put marks on the grips or the fixtures used to hold the specimen. Now it won't account for, there's going to be slippage, it won't account for that, but at least it'll be better than just the crosshead movement. Also, if you can get a longer specimen, then you could put dots on the specimen itself to use the video extensometer.
And Ralph, let me jump in. You mentioned there could be slippage. I think what you're saying is there could be a little bit of extrusion of the sample from the grip itself, and that would affect a little bit the modulus measurement. And I think that's what you're referring to, right?
Correct.
Yeah. But it's not that the sample slips out, it's just that it pulls somewhat from within the grip faces, affecting measurement. So you're talking about trying to get as accurate as possible a reading.
Right. Right. A small amount, but that could, if you have a small specimen, that could really affect your overall measurement. Yes, you're correct. Thanks for the clarification.
All right. I'm going to jump over to the next question if everyone's good with that. We're working with 5944 and performing stress relaxation test with indenter at certain indentation around 30% of sample thickness. Is there any way to increase accuracy of the test? Because at least 2% of error we're getting for indented depth. I think, yeah, error from what? The expected value. Anybody want to jump on that one?
Ralph, you can go ahead.
Okay. So the way I read this question is we have a flat surface and our specimen is here, then we have some sort of indenter, and we're coming down and we want to contact our specimen and then indent this 30%. And apparently there's some error in that's, again, how the assumption I'm making, there's some error in here. So there's a couple things that you can do. Again, it depends on the system that you have and what we're trying to do with the specimen, those sorts of things. But you could have a preload setup. We come down, touch the specimen at a certain load, make it very small. So as soon as we touch the specimen, now we reset the gauge length, and then we drive down an extra 30% from there, additional 30%. That would be one way to correct the problem. You could, depending on the fixtures, we could set some type of extensometer or maybe even an LVDT to give us a more precise measurement. That might be more in the custom fixture realm, but those are possibilities of all things I've dealt with in the past. Dan?
Yeah, so I guess that, to add on to that, it seems like, so any questions like this where we're making some sort of presumption to answer your question. We just want to make sure that if we do hit the nail on the head, just let us know in the question panel, and if not, also let us know so that we can reach out to you directly and just have a conversation about what problems you're having. So I was going to answer it similarly, Ralph, in that if there is some sort of slack in your fixtures, that could be a source of displacement error if you're using the crossheads displacement.
Good point.
Okay. We're going to jump to the next question. Even if we're calibrating the device before every measurement, it is still not well calibrated. How can we have better calibration? Go ahead, Dan.
So again, here, I think I'm going to make a little bit of a presumption that when you say that it's not well calibrated, that you perform the electrical shunt calibration that's in the software, and you just don't touch the load cell, you don't touch your fixturing, and you see that the load
Uh-oh. Did anyone else lose Dan?
Dan is frozen.
Dan is taking a dramatic pause. So we're while we wait for Dan to return to us, does anyone else want to field this question, or should we hold it for him to come back to?
Go for it.
I'll jump in just a little bit and just say, sometimes when questions are raised about the accuracy of a calibration, often it can be the size of the load cell that may be the issue. So, we can calibrate it. We're doing the shunt calibration that Dan was just talking about, but that shunt calibration should be very good to the accuracy specifications of the load cell itself. So the load cell, I think, generally is not the source of the error. It's often some sort of a methodology kind of thing, and sometimes it's an equipment setup. So we just have to, one thing I would look at is to make sure that we've got the best load cell for that particular test so that we get as accurate a result as possible.
All right, Dan's back.
Apologies there. I think I'm back. I'll keep talking. So I hope, I'm not sure, I think it sounds like you got to the shunt calibration part, but I guess what I was going to say is that if you do see load cell drift occurring after you've performed the shunt cal in the software, that it's possible that you could have damaged your load cell at some point. So you could have run your fixtures together accidentally. If you have a very low force load cell, that this is very, very easy to do. And if that's the case, that we might be looking at a replacement load cell if that's the diagnosis, but that's just something to look out for.
So another thing that many customers have done is they will purchase weights, especially if you have a small capacity load cell. And if you have a 5 kilonewton, 1,000-pound capacity load cell, you won't be stacking 200 or 300 or 400 pounds. But if you have a load cell that is, say, make it up 100 newtons, maybe you just take a small weight that's, say, 10 grams or a couple of 100 grams, and you know that that's a known mass, and every time you hang that 100 gram, 200 gram mass, you should read the same every time. Of course, it'll be within the error margin of your load cell. The other thing that I've seen people do is they would like to have a reference material. So say in tension, for example, polymers, films, kind of tough to do just because of, as we know, temperature, humidity, different things affect them. What a lot of folks would do is use a high quality medical grade fine wire. Typically within that spool, the load will be the same. Usually it's somewhere like a 0.05% error throughout that entire spool. So now you can keep that spool, run your tests, and you should, again, have the same measurements. And the stainless steel wire stores very well, so you don't have to worry about humidity, temperature changes nearly as much as you would with polymers. That's another thing I've seen customers do. Compression springs, again, those high quality springs work well.
So let me jump into it and just say, Ralph, you're talking about just making sure, test to test to test, the load cell is still reading what it should read. by
Correct.
using, if you will, a standard or something which is consistent over time to make sure that the load cell hasn't been damaged, especially important for low force load cells.
Exactly. So sometimes we make an assumption that the load cell's off, but then we do something. We hang a weight every day, every month. It's just a spot check. What I refer to as a sanity check. Is the load cell calibrated, or is it reading properly? So if you hang, say, a light weight, a medium weight, and a heavy weight, and you do that every day or every week, it's a quick check.
Yeah, and that makes sure that not too much time goes by before you catch something in maybe the fixturing setup or damage that's occurred or something like that. You can catch it quickly before a bunch of tests have been done.
Right. Yeah. And then some errors are introduced where we think maybe the load cell is not calibrated properly. But what happens sometimes is if we're changing load cells out, maybe we forget to torque the load cell down to the proper tightness. Sometimes the fittings on the grips or fixtures, we won't have a snug load train. So if there's a lot of slop in that load train, it'll make it appear that the calibration is off just because we have too much slop in there. So those types of things can help firm that up as well. But as Dan said, it could just be a damaged load cell.
Yeah, and then another trick for checking a load cell, Dan, you mentioned drift. For example, if the load cell is reading and maybe in 5 or 10 minutes it reads a different value. So one thing which can be done as well is to, just set a test for the load cell to sit with no force on it and just watch the trend of that force over 5-10 minutes and just see, is it consistent and steady or is it drifting? Now, Instron load cells are temperature compensated, so they're supposed to be as immune to load change or force change, temperature changes, as possible, so that the load is consistent. But one way to just verify that is to watch that trend over time. And I think this question can sometimes be related to, how long should I let the system warm up before I begin a test?
Good
So
point.
Monday morning, I come in, I turned the machine on 2 minutes ago, and I ran my first sample, and I'm getting results that are consistent with the tests that were run Friday at the end of the day. So it is good to let everything warm up a little bit so that it is isothermal. Even though everything is supposed to be temperature compensated, it is best, good practice, to have everything as isothermal as possible during the test when you're seeing, small variations and trying to get that last little bit of accuracy out of a test system.
All right. I feel like you had a good solid answers on that one. So if everyone's cool with it, I'm going to jump on to the next question. All right, cool. So do you recommend elongation tests on soft tissues to measure Young's modulus? If yes, what is your gripping solution for that? Don't all jump at it at once. Oh, there we go. We got a taker.
So I guess this is pretty similar to a couple questions ago, talking about soft tissue modulus calculation. So again, I guess first, let's just see how big this sample is, so that if that's going to tell us whether or not we're going to be able to grip it well and consistently. And if it is properly sized, then generally to our bio customers, we have a selection of side action grips, some manual, some pneumatic, that also have a variety of jaw faces. So for more sensitive tissue material, we're probably going to point you towards a rubber coated jaw face. And in terms of manual versus a pneumatic side action grip, we have some very low capacity pneumatic grips that are good for applying a very consistent low amount of pressure that no matter who your operator is, they can apply the same clamping pressure to your sample. So that's probably going to be our recommendation. Manual grips work as well, but you do just have to be aware that you are using your own hand to torque and to apply pressure to the sample, which if our pneumatic offering is too much pressure, then maybe that is what you need to do. But at the same time, you have to be aware that your operator should be very experienced. You shouldn't be changing operators all the time, because someone might clamp at one pressure and another person's it's gonna be impossible to replicate test after test with different operators.
Any other thoughts on that one? All right, Mark.
Yeah, I was just going to say another benefit of pneumatic. Dan, you just talked about it helps with consistency to use pneumatic if possible, so that you and I test in as much the same way as possible. But another advantage is that, especially for biomedical samples that may be a little slippery, again, when we clamp, the pneumatic is there and it's continually trying to squeeze, whereas with a mechanical grip, when I tighten it initially and the sample pulls, and like Ralph mentioned, it may extrude just a little bit from the grip, the volume trapped in the grip goes down, and so the clamping pressure goes down. And so for slippery samples, if you will, a pneumatic can be helpful because it's continuing to grab, even if the sample extrudes just a little bit out of between the faces, it continues to follow up and continue to clamp with a consistent force through the test. It's another advantage besides consistency. It also helps with holding the sample and not letting it get away or actually slip out, which can be a problem with some biomedical samples.
All right. Feels like a good point to move on to maybe our next question, which does look like it's still on the kind of similar topic of the calibration load cells. How calibration can be accurately done after changing the load cells. And in my Instron 100 kilonewton load, how can I change my load cell though I don't have titanium rod for changing the load cell by stretching up to 100 kilonewton? Is there any other technique? Go ahead.
So the first part of the question about how can I accurately perform the calibration when changing the load cells, we just want to be clear that in terms of calibration, there's an electrical calibration that is performed in the software, and that's just with the touch of a button, and that's what we call a shunt calibration. That's bringing the load cell almost back to its factory settings, you could say. A lot of people think that when we say calibration, it's what we were referring to when, say, an Instron field service engineer comes to your site and he's putting a reference load cell in the midst of your frame, and he's comparing the load of that reference higher accuracy cell to your load cell to verify that it's actually reading the correct loads. So going back to the first, that when you change out load cells, all we need to do is it's plug and play with an Instron load cell. So you can have a 5 kilonewton load cell, and we can be running tests, and then you say, okay, I need a smaller capacity load cell, and you can dismount the 5 kilonewton. You can bolt on a 1 kilonewton load cell, and when you plug in the connector into the load channel, that if you've actually performed this electrical calibration on that load cell with that frame before, you should just automatically see live readings and its connection should be made. If it's a brand new cell or if it's a new frame that you're putting this load cell on, then you can go into your system settings and you can perform the calibration with no fixtures attached to the load cell, and you'll be able to use the load cell. But in terms of verifying the actual load values to make sure that they are correct, that you need some sort of reference device. So that's where our service group comes into play, where they have reference standards to perform these verifications, and not only perform the verification, but you're receiving a certificate, an accredited certificate that a lot of labs require, that says that this verification was performed by an engineer via an accredited test lab, so that you can trust everything that's on this certificate. Ralph was referring to a spot check device. So that's kind of more of a sanity device that some labs employ to do a daily check, to make sure that you're not going to have one of our field service engineers come in every day to perform this calibration. It might be once every 6 months, once every 12 months, but you don't want to go 3 or 4 months using a bad load cell, because that could potentially cause downstream problems with all of the data you had just collected. So in that case, you might not need an accredited person performing this spot check. You could just simply have a set of weights that has some traceability to them that you can purchase from a Mitutoyo or some sort of reference supplier. So that's good. And that's just kind of a lot of information about the two different types of calibration. If you're just using one load cell and then want to use another load cell that you've have already used on that system, you should just be able to unbolt, bolt the new one on, plug it in, and you should be good to go. And in terms of the second part of the question, so the titanium rod, I'm presuming, is just the through bolt, the bolt that goes through your crosshead. And you're right that for our larger capacity load cells, that these are massive bolts. They're torqued incredibly hard down onto through the crosshead, and it's not easy to take it off. They weigh a lot. So there are a few different techniques. The main being you can piggyback load cells. So the clevis connection that exists on our frames, you can essentially have a load cell that has the male equivalent that you can simply do a pin-in clevis connection and keep that higher capacity load cell bolted on, never take it off. And when you need the lower capacity cell, you can simply just pin it in place, lock the check nut down, and then you're good to go once you just swap out the connectors.
Any other thoughts after that?
No, that was good. That's what I was, what Dan said about the piggyback connection. Yeah.
Okay, perfect. I am seeing someone with their, yeah, go ahead.
Yeah, I was just going to say, so the piggybacking avoids the need to take the larger load cell off to begin with. That's even better, right? So now you don't even have to take the larger load cell off. The only disadvantage is you need to make sure you have enough test space. So many times you have the test space, usually you do, but you might not, depending on which type of system it is. But usually it's just take one load cell and you put it underneath the second one. Really easy, and it avoids the problem to begin with.
Okay, great. I did see someone with their hand raised for a little bit. Just kind of want to point out that probably the easiest way to, if you do have a question or kind of want to get our attention, the best way is use the questions panel, because we are kind of monitoring that pretty closely. So if you do have something you want to plug in there, just let us know. But we're going to jump over. It looks like we're going to switch gears a little bit and answer this question. When do most labs require or move toward meeting 21 CFR Part 11 compliance? All right, yeah, go ahead, Ralph.
So, and actually, John and I had this conversation relatively recently. So in the United States, what I see is there's two extreme ends. So one end being the pure R&D or just the product concept stage. We really don't have it nailed down. We're just kind of thinking of an idea. The other end being more, this product is on its way out the door to be used by the end user, and I want to test it before it actually gets on the truck. So on this end, 21 CFR Part 11 is typically required. Over here on the extreme end of the concept R&D, usually most customers don't require it. But then you have this gray area in between. So usually on this extreme end over here with the R&D product concept, as soon as you go to that next step of development, and now we're going to move this into the development stage and whatever stages are along the way, this is when you want to start having the 21 CFR Part 11 and then every step along the way until you actually send that out the door. John, what do you see on your?
Yeah, you're muted, John, so check that real quick.
I was just saying there, you're right what you're saying, the pure R&D end of things tend not to be as concerned about Part 11 compliance. But if you look over this part of the world, we have, well, in Ireland, a lot of multinationals who have, we'll say, sister sites in the US. They have operations here, they have operations in Europe, and even across the same company, we've seen that gray area you mentioned, Ralph, we've seen that gray area differ between from site to site. So I think there's a few sides to that. I mean, large companies will say, big multinationals tend to have fairly uniform requirements across their sites. So what I've seen is, okay, you have obviously the QC end of things, the production control and so on, absolutely have to have compliance with Part 11. Whereas that gray area of method development and R&D, although it may not necessarily need it, they may have it there as a requirement for basically putting a machine on site and actually using it on site. And I've seen a situation where a machine which is destined for the very early stages of R&D, they go through the whole process of ensuring to have Part 11 compliance, IQ/OQ validation, the whole works. And I think that's really down to the company's interpretation of what they actually need themselves. I suppose another part of it as well, okay, we're talking about the path, we'll say, from R&D all the way to the end product. And the other part of it that's, I suppose, part of the production end of things is incoming raw material quality, where it's absolutely important that they have compliance and there's traceability from that side of it. As well as, we'll say, FDA requirements in Europe, we have to think about local requirements from local regulatory authorities, but there's a lot of harmonization between them. So I think if you look at companies who are compliant with FDA Part 11, 21 CFR Part 11, all those requirements will feed across and they will actually be in a good position as regards, we'll say, any of the European or even Japanese authorities. And just going back to what you're saying about method development, what I've seen in the past, not necessarily more recently because it seems to have tightened up in recent years, but in the past where you have, we'll say, problems down the line when we look at QC, for example, where we have a test here and this is used for release of the product onto the market. After so many years, you may see problems with the method and so on. And then after a bit of investigation, people realize the method is actually not what it should be. So there may be, we'll say, a slightly substandard method. So to kind of get that earlier in the whole process and actually find out what was going on at an earlier stage, I see where we'll say the method development functions and even going back to even the pure R&D end of things, where they're having to be more stringent about traceability, data integrity, and so on, which is obviously a huge part of the landscape in this industry. And well, even the data integrity we've seen in the last 5-6 years has become a lot more stringent as well. So, I mean, I think the whole area is quite large. You could have a whole seminar on that on its own. And if you look at, we'll say, company to company, there's differences in how they implement the regulations. They're all compliant with the regulations, but how they interpret it and how it actually looks in the actual lab can differ. So, if you go back to, say, IQ/OQs, for example, whether they actually need an IQ/OQ back in R&D or not, you walk into one company who makes a product, you walk into another company who makes a similar product, and they could have a completely different view on it. That's not saying one company is compliant and the other is not, but it's just the internal validation requirements in those companies.
All right, any other thoughts? If not, I'm going to sign John up for hosting his own future webinar on the topic. So thanks for finally volunteering for that. So that would be cool. We're going to jump over to our next question. My test is a repeated series of ramps and holds. Can I make that series of steps one cycle?
Yeah, okay, I'll take that one. So this often applies to fatigue tests because it's repeated loading. And you can. So if you're doing a fatigue test of some kind, you're likely using wave matrix. And in wave matrix, there's a feature in the system where you can loop again and again. So say you want to ramp, hold, ramp, or something else that you can loop. And the data for the loop has an option. You can change what a cycle definition is. and you can say, all right, each loop, each repeat of this sequence is one cycle. So it could be, load, hold for 5 minutes, and release. And that, as far as you're concerned, is one cycle. So it's in there. And the thing to look for is default cycle definition. It's in the help system, and that'll lead you in the software to where the setting is.
Yeah, go ahead, Ralph.
So Mark's taken our fatigue expert. He's taken it from the wave matrix dynamic point of view. Well, you can do a similar thing with just a simple instrument like this, universal. So there, if you have Blue Hill Universal, you can have our test profiler. And within test profiler, you can have a ramp and hold, and you can also set up a looping function, and then you could set up different triggers and events to get you out of that loop, go do some other things. Something happens here, go back and go in that loop again, and then continue on.
Yeah, John.
Just a very brief one. I've had this question before about the actual, we'll say, number of, we'll say, call it blocks that you can have in a whole sequence. And I know you're talking about the loops and all that, and I just wanted to add in there to what the guys are saying is that if you put in a loop, it's not each time you go to loop, it's not adding on blocks. So it's just we've had this question like, where is there a limit to the amount of we'll say different functions you can perform in a test, whereas the loop function, you could have two actions, we'll say, inside that loop, and that's just two blocks that's just repeated over and over again. I just wanted to throw that in there just to clarify slightly.
All right, feels like that question's answered. So this next one appears to be about IQ/OQ. Should IQ/OQ be performed by the equipment supplier, or can we do it ourselves? Any takers? Ralph? Yes, tentatively Ralph.
So I feel this question quite a bit as well. So yeah, a lot of times customers ask me, can they do the IQ/OQ? I mean, absolutely, certainly. So either the vendors can do IQ/OQ or the customers can do IQ/OQ. Frankly, I just tell the customers it's really your time versus your money. So if you've done the IQ/OQ on things like an Instron or whatever it is in the past, and you have the documentation made up, then it's going to take, you would make it up 2, 3, 4 days to do your IQ/OQ. And as long as you're okay with that, then that's fine. Otherwise, if you don't have the 2 or 3 or 4 days, then you can have Instron do it, and it'll cost you more money, but you save the time. Now, if you're in a situation where this is the first time you've had this type of instrument or equipment, you don't have the protocols made up, now maybe it's going to take you weeks to develop the protocols. Maybe you want to have the vendor do it because they have the documentation. They could do it in 2 or 3 days versus what might take you 2, 3, 4 weeks.
Yeah, go ahead, John.
Just add in a little bit as well. If you look at an IQ/OQ document and the operation of the instruments, like, you can have a lot of, we'll say, complex, intricate kind of steps involved. So if you take someone like ourselves, Instron, producing the IQ/OQ document, we know the instruments intimately, and we know all the functions that need to be checked. Whereas if you're the customer, you're checking just the bare minimum that you need yourself. There's also a chance you might miss something critical that could be picked up later on, in which case it causes a problem with your IQ/OQ. The other side of it as well is consistency. Like, if you have, we'll say, 2 different sites not speaking to each other, which, even with the same company, is not unknown. We've seen, I'm not going to obviously name any companies, but we've seen companies here at this part of the world not speaking to their sister sites in the US. So if you have 2 different people in 2 different sites producing their own IQ/OQ documentation, chances are they're not going to be very consistent. Whereas if you look at the manufacturer produced IQ/OQ documentation, you get that consistency. And now, if you look at Instron's case, we have our IQ/OQ document production, we'll call it, centralized. So if you have your US site using Instron IQOQ documentation and a site over this part of the world, the documentation is going to be identical, which makes it a lot easier for, say, method transfer and so on.
Any other thoughts on that one? No? Okay. Looks like we're jumping over to more of an application question with this next one. How can I accurately measure the elongation of a thin catheter? I have a clip-on extensometer, but I'm concerned it could be interfering because it hangs on the specimen. Yeah, John, take this one.
I suppose there's a couple of thoughts on that one. It's not necessarily just for thin catheters, but we'll say filamentous type materials and so on. It is a consideration. Yes, you put the clip-on extensometer on your specimen, and you do have the weight of the extensometer on the specimen. Whether that causes any effect or not is something I suppose you would need to test for. So if there was some way you could actually run a test with and without the extensometer. As an alternative, what you could look at is other types of extensometers, and we mentioned earlier in the conversation the video extensometers, which is completely non-contact. So you could look at the video extensometer. It's not going to physically interact with your specimen at all. The other potential option there is a long travel extensometer. So it does contact the specimen, but the weight of the extensometer is not on the actual specimen itself. So I suppose it's something that would need a little bit of investigation as regards the method and what path you take. But certainly it would be something that you need to look at to see, is the weight of the clip-on extensometer affecting what's going on with the sample. But there are other paths you could take as well.
All right, Dan, you look like you want to jump in there.
Yeah, so something I want to add that I always try to have the conversation with our customers about extensometers is that sometimes they're not always needed. So like, what are your requirements? So in this case, if it's a catheter, how much elongation are we talking? If it's incredibly small, then yes, that's probably a good reason to use an extensometer. But if we're talking 100, 200, 500% strain, that we could use our crosshead position without using an extensometer to get a strain value. And one part of that conversation I have with customers is, do you need absolute accuracy for if you're calculating elongation or modulus, or are you looking to compare two of your own products? Because if you need absolute accuracy, then yes, the device that you're using needs to be incredibly accurate, and that's why we generally encourage the use of extensometry. But if I'm trying to measure catheter A versus catheter B, and that's all I care about, and their relative difference is really what I'm after, that's a case where you might not need an extensometer, that you could grip them the same way in the same system, get two different results, and there's your relative difference. The absolute accuracy might be a little bit off, but if you're only after the relative difference, then you can rely on the crosshead measurement for that. As long as you're not going crazy different loads and such, but if you have similar forces, then you can rely on it.
Yeah, go ahead, Ralph.
So so two things. One is another technology we have is the automatic extensometer. So you could use that because that does have a very light force, and the motors keep the weight off the specimen. But to Dan's point about do you need an extensometer versus not, I can't tell you how many times folks have purchased an extensometer for their lab, and the next time I visit, it's sitting in the corner off the instrument, never to be used again. So something to consider.
All right, good points. So we are at 10 minutes left. It's kind of crazy. We're already 50 minutes into this thing. Lots of good questions so far. Certainly, if you have some more questions, like keep sending them in. We'll probably get to maybe a couple more. But yeah, just kind of wanted to mention that. Again, we'll follow up with people if we can't get to your question live. We'll jump into this next question. So what are Instron's capabilities for simulating environmental conditions in the body? Dan?
So our standard offerings around environmental chambers, I guess you could call them, there's two main ones that we use and point our bio customers towards, which generally are customers who aren't looking to go to 100, 200 degrees Celsius. We're looking at 37 degrees C is body temperature, so a device that is around that temperature. So two different options. One is our bio box. So our bio box, it is an enclosure around the entire frame, and so the frame itself and the fixtures and your specimen can be controlled from ambient temperature to 40 degrees Celsius. And the second standard offering is our BioPulse bath, which is if you're trying to achieve submerged testing. So if you're using some sort of saline or water and you need your sample submerged in that during your test and also at a certain temperature, then we allow for up to 37 degrees C for our BioPulse bath, and your specimen will be submerged during the test. So those are our two standard offerings that generally customers will choose between.
Yep, go ahead, Ralph.
So just to, and what Dan says, right, but just to, we're not sure what the type of instrument we're thinking about. Are we looking at more of a traditional 1 or 2 column tensile compression, or we're looking at fatigue? So we can have both of these on either the fatigue instrument or the tensile compression, the static.
Okay, everyone happy with that answer? Cool. All right, John.
Very quick one.
Yeah, go ahead.
We have the BioBox, we have the BioBat, but not to forget our standard environmental chambers, although they are, I suppose, designed to go to a broader range of temperatures. If you look at, Ralph mentioned the dual column, it is an option as well to use the standard chambers at that kind of temperature.
All right, good point. Dan, all right, coming back to you, let's go.
So the reason why I almost hesitated saying our standard chamber that we definitely sell the most of in terms of these environmental chambers, that if you are purchasing a environmental chamber that it can go from around -80 C to 300 degrees Celsius or so, that when you are in the ambient region, so say between 20 and 50 or 60 degrees Celsius, that we want those customers to be very careful about reading the manual, and because you will achieve overshoot depending on how you've conditioned your chamber. So in those cases, if you are trying to use a relatively low temperature in its range, just make sure you are reading the manual on how to program the controller on board to ensure that you're not zooming past 60 or 40 C, which will happen if you don't have that configured properly.
All right, before I jump to the next question, any last takers? Okay, cool. So I think we're gonna make this our last question. We've got 5 minutes left, so we're just gonna kind of jump into this one and then we'll wrap up. I'm running what's supposed to be a sine wave fatigue test, but the waveform is distorted. What can I do to make the waveform more sine-like?
All right, I'll take that one. So fatigue tests are typically run with dynamic systems, and for biomedical testing, a lot of that test is done on a standard electromechanical type system, a universal tester. And so people don't necessarily know that there are actually gains on both systems. On the electromechanical systems, they're kind of behind the scenes, but in dynamic systems, if you were to test, for example, a titanium hip replacement component versus, say, tubing, right? That was the question we had earlier. Those require different setups to the system, and it's really the same kind of tuning that Dan was referring to on chambers to make sure that we've set it up correctly. So the most common one is to make sure that the system is tuned for the sample which is being run. And again, in the manual, it'll talk about tuning for the sample, so an awareness of that. Beyond that, a lot of biomedical samples can be nonlinear. So for example, take a tissue sample, a skin sample. As you pull on that, in one region, it's very loose, and then all of a sudden it goes tight. And that nonlinearity can cause what's supposed to be a sine wave to not look like a sine wave. And so for that, we have special tools in Wave Matrix. So there's trimodal control and advanced amplitude control, which will help us on nonlinear samples to run. Another, maybe an easy example would be, for example, take a hip joint. It's kind of a ball and socket joint, and when it's initially first tested, they'll be nice and tight, but over time, maybe some lash will develop. We spoke about lash earlier in the session, and if we're trying to control that in load, it may not give us a very good-looking sine wave, but trimodal control and amplitude, advanced amplitude control are tools we can use for that. So it goes beyond just having good tuning for the sample. It actually helps us with the application. So those are things people can look up in the manual, and there'll be information on how to set that up for your test.
All right, everybody good with that answer? Okay, cool. So we're gonna wrap things up. But I do want to leave on a couple quick notes before we go. So in about an hour, I'm going to be back here with Elaine Gordanoff hosting a session called Protecting Data Integrity and Having Traceability in Your Testing. And then tomorrow is our final day of the Instron Biomedical Testing Open House. So if you'd like to attend any of the upcoming events, make sure to head over to instron.com to sign up now. And the recording from this session is going to be available on our YouTube channel in just a bit later. We're also going to email all of you a link to the recording, and then just a reminder that if you are interested in receiving the single-use code for free access to the Essentials of Biomedical Testing e-learning course, there's going to be a survey in just a second when we close this session. You just want to indicate whether or not you want access to that in that survey. So with that said, I want to thank all of our panelists. Great job. Thank you for participating. That's fantastic. And thanks to all of you for attending. We really appreciate your time. And we really hope you're going to come to any of the upcoming sessions. Take care, everyone.